Hello! In this fifth and final video, we're going to be taking a look at quadratic word problems, which is topic 5 from your quarterly exam this Thursday. In this case, we're looking at these problems that refer to throwing something in the air. So in other words, we're modeling a quadratic or parabola shape, representing the height over time. We've seen this problem before, but in this problems like this before, I should say. In this case, it says Jim throws a stapler in the air. Its height in feet after t seconds can be modeled by the function h of t. We want to find the highest point and at what time this occurs. And it's also good practice to know how to do this without the calculator. Oftentimes problems like this say justify your work or explain things. So if you know how to do it on the calculator, that's good, but you might miss out on some of the kind of showing your work portion of it. So anything referring to the max, think about if you're throwing something. Okay, the path of it's going to look like this, right? And eventually it's going to hit the ground again. Anything referring to the maximum height is referring to the vertex. The vertex is either always a maximum or a minimum, so in this case when we're throwing something, it's referring to a maximum. And we can start finding these values by finding our axis of symmetry, or the x value of that point, or in this case the t value, how long it takes to reach that maximum, which is the negative b over 2a formula. In our quadratic that we're given here, our little model, b is simply 54. Remember a, b, c here. C we're not going to use till we do some quadratic formula stuff, but it doesn't hurt. And a is negative 6. So it's going to give us negative 54 over negative 12. Obviously, the negatives are going to cancel out. Wouldn't make much sense to get a negative time value. And 54 divided by 12, you could double check on your calculator, should be 4.5 or 4.5. So what does that represent so far? The maximum height of this stapler occurs after 4.5 seconds. So we've answered kind of part 2 here. Part 1, what's the actual height, would be us evaluating 4.5. So this you could either enter into your calculator and just check. You would have to adjust your table, or simply evaluate 4.5, basically plug in 4.5 for t. This is just some calculator work. This would be all qualify under kind of the, hey, justify your answer, explain your reasoning, which tests and Regents questions like to ask a lot. Okay, and I'm going to enter this on my calculator. You can either enter it in as one string, exactly as it looks. Things get a little tricky if you try to break it up into pieces. You might leave something out. So I'm literally typing in the right-hand side here using parentheses, squared, and I get 126.5. Okay, you could use the graphing feature, but I think it's easier just to kind of type it in. So the highest point is at 126.5 feet. The max height, and that occurs at 4.5 seconds, 4.5 seconds. Obviously you could write things a little fancier than I did here. So once again, this is an application of can you find the vertex or axis of symmetry and know how to differentiate between x, or in this case t, and h of t values, time versus height. You don't want to obviously say, oh, the maximum height is 4.5 feet. Okay, knowing the difference of what t represents and what h of t represents. Also required is knowing the negative b over 2a. That's something that you have to bring into the problem because that's representing your axis of symmetry. Okay, thank you guys for watching. If you have any questions about any of the topics you've seen, topics 1, 2, 3, 4, 5, be sure to let me know before Thursday, and take care.